Welcome to EDU World Space.
In this problem, we have a particle that traces out an Archimedean spiral as it moves, and it traces out an Archimedean spiral defined by r, the radius, equals 8 times theta feet. The particle moves
Here's a
with
clean and
a
professionally formatted
constant
presentation of the calculation shown in the
angular
image.
velocity, theta dot is 4 radians per second, and we want to find
Application of the work
the
energy theorem,
transverse
WET.
and
From the work
radial
energy
components of the
theorem, the force
velocity
F is given by
when
F
theta
equals
is
frac
pi over
text
2
KE,
radians.
where
So I've
KE
written out
equals kinetic
the
energy, S equals stopping distance.
formulas for
When given for
those.
object A,
These are the
FA
radial
equals frac
components of velocity and
100,000,
acceleration,
0.10.
and these are the
For
transverse
object B,
components.
FB equals frac
If you look at these
225,
equations, the
1500
main
equals
thing that we're missing
0.15
from
text
these
makes
givens
and
is
force
theta
ratio frac
dot and
FA,
r dot.
FB equal frac
For
0.10,
theta dot,
0.15
or
equal
theta
frac
dot
2
dot,
mole
excuse me.
result.
For theta
Lambda
dot
box
dot, this is
frac
just
FA,
the
FB.
time derivative
Would you
of
like a
theta dot
PDF
again, and
version
since
of
this is
this
constant,
explanation?
this is 0, as I've written out here. For r dot, this is a little trickier. R dot is dr dt, and we have r of theta, so we could find dr d theta, and we have d theta dt. So these would actually be equal because the d thetas would cancel, so that would give us dr dt. So dr d theta is just 8, since r is 8 theta, so dr d theta equals 8 feet per radian, and therefore r dot is 8 feet per radian times 4 radians per second, which gives us 24 feet per second as our instantaneous radial acceleration. So if we look at that, we'll find that if we plug all this in, UR is going to be 24 feet per second. U theta is going to be R, which is at pi over 2 is 4 pi times theta dot. So 4 pi times 4 is 16 pi feet per second. And for the acceleration, this is going to be r dot, which is 24. So AR is 24 minus R is 4 pi times theta dot squared is 4 squared is 16. So 24, we can factor out a 8 here. So we'll get 8 times 3 minus 8 pi, and this will be in feet per second squared. And for the should be a theta, not a phi. For the theta component of this, the transverse component, this is going to be r times theta dot dot, which is 0, times r dot times theta dot. So 2 times r dot, which is 24, times theta dot, which is 4, which is 2 times 4 times 24 is 96, which is 200 minus 8, which is 192. And that's in feet per second squared. And those are our solutions. Our solutions. And the next portion of this problem asks us to sketch out what these look like. So UR and U theta are both positive. U theta is going to be somewhat bigger than UR because this pi will treat it about 3, so it's maybe about twice as big as UR. So we'll draw the theta, the transverse component in red here for the velocity. So UR is going to be like that, or U theta is going to be like that, and UR is going to be like that. So that we have about that for R hat, or excuse me, V hat, or V, just the vector V. And then R theta. And then if we look at the acceleration, which we'll do in blue, the R component is actually going to be less than 1. It's going to be less than 0. It's going to be negative because 8 pi is much greater than 3. And if we plug that into a calculator real quick, 3 minus 8 times pi is negative 22 times 8 is minus 177. So these are about equal in terms of the magnitude of the transverse component versus the radial component, but the transverse component is slightly bigger. So it's going to look something like, I'll draw it down here. That is the direction for the transverse component, and this is the direction for the radial component. So A is going to look something like this. A theta, AR. And we can go ahead and lay that on our thing just so that everything is in the picture. And that's what the situation will look like if we sketch it out. And that's how you solve this problem.